This is the Introduction to Advanced Algebra 2. I'm Mr. Stark. We're on topic 5, which is titled Solving Equations Graphically, Numerically, and Algebraically. And this is lesson 5a, Solving Equations by Graphing and Factoring. Most of our work is done algebraically, but the graphing piece is really helpful because we could see the solutions or confirm our solutions. You can follow along using this document, and we'll start with the graphical approach. Solving graphically on the TI-84 calculator is fairly simple. We just have to get familiar with the process. And when we find solutions on the graph, we're finding the x-intercepts. Before we go to the calculator, let's write down the steps that we'll take. We'll press y equals to graph the equation. We'll press trace to estimate the solutions. And we'll press second trace, which is the calc menu, to find the zeros. When we find the zeros, we'll simply follow the directions on the screen, and then we'll end up with two solutions. Okay, let's go to the calculator. I'm on my TI-84 calculator now, and just wanted to let you know in the bottom it has a key press history, so you could see all of the buttons that I press. So here we go, follow along. The first thing I'll do is just go to y equals, like I said, and enter in this equation. So 2x, then the squared button, minus 3x minus 2. And we don't enter in equals 0 or anything like that, just the minus 2. And then we'll find when it's equal to 0. Then we'll press the zoom 6 button to get a standard window, and mine probably comes up quicker than yours. Press the trace button so that we could just move along the curve. So I want to show you to the left, if we go near the x-axis, that's where y equals 0, we could see how the y values just kind of bounce up and down near 0. And then you could see the other solution, the other x-intercept, and you could see how the y values are close to 0. But sometimes we could get on 0 and sometimes we can't. So to get the exact zeros, we go to second trace. So I just kind of put my cursor back in the middle. Second trace, we'll choose the 0 option, which is number 2. And then there's a series of questions that pop up. Left bound? So let's find the left x-intercept first. So we'll go to the left of the left x-intercept. And I kind of go just more than I think is needed. So I know that I'm going up, but I'm also going left. So I press enter, and then right bound. So I need to move to the right of that x-intercept. So I go close to x equals 1. Somewhere to the right of that, doesn't matter. Now I have an interval, a window, in which the calculator is looking for the 0. So I move towards the 0 and I press enter. And that's my guess, and therefore the calculator finds out that the first 0 is negative 0.5, meaning x is negative 0.5 and the y value is 0. So I press second trace again, 0, and it'll ask the same questions. So this time I simply move to the left of the right x-intercept, which means I had to move to the right, and then move to the right, press enter, and then guess again. So that one results in 2, 0, meaning the 0 is located at x equals 2. So we found both of our zeros, and it just so happens that the power of the function is squared, so there's a 2, and the number of zeros are 2. Many times that happens, not all the time. So because there could be a quadratic function or parabola that simply sits on the x-axis, so therefore it would only have 1, but it could also have 0. And that is how to find the zeros or the solutions on the TI-84 graphing calculator. Solving quadratic equations by factoring calls upon those skills that you learned in Algebra 1. And in these two examples, we'll use the zero factor property. It assumes that A and B are real. And it says, if A times B equals 0, then A equals 0 or B equals 0. Hey, that makes sense because 5 times 0 is 0, and 3 times 0 is 0, and negative 15 times 0 is 0. Let's check out the first example. Solve x squared plus x minus 42 equals 0. So we have to factor first, and what we're going to do is factor into two binomials and set that equal to 0. We have to figure out what goes in the binomials though, and that's that process of factoring. We should know that the first terms of each binomial is x, because x times x is x squared. But we have to play around with numbers to figure out what else goes in there. So let's think about this. We have to figure out two numbers that multiply to negative 42 and add to 1. So let's think about the factors of 42. We have 42 and 1. We have 21 and 2. And 7 and 6. If we use 42 and 1 and make one of those numbers negative, there's no way to add or subtract to get the number 1. Let's try 21 and 2. If 21 is positive and 2 is negative, then we get the negative 42, but then we get 19. And if 21 is negative and 2 is positive, then we get negative 19. Okay, it doesn't work. And we're left with 7 and 6. If we let 7 be negative and 6 is positive, we get negative 42, but we get a negative 1. But if we let 7 be positive and 6 be negative, we still get negative 42, and we have a positive 1. Phew! So we have x plus 7 times x minus 6 is equal to 0. Now we could apply the 0 factor property, and we get x plus 7 equals 0, or x minus 6 equals 0, and we solve each of those equations for x. We get x equals negative 7 and x equals 6. Those are the solutions to that equation. And if we graph the equation, those x values will be the x-intercepts. The next example is a little harder because it has a coefficient of x, but that number is prime, so it's not too bad. So let's set this up. We have two binomials. In the first binomial, we have 3x. In the second binomial, we have x. So let's play with numbers again to see what else goes in there. Let's try putting a 4 in the first binomial and a 1 in the second binomial and see what the outer terms and the inner terms would equal. So we have 3x for the outer term and we have 4x for the inner term, but we're trying to get negative 11x. So can we do that? We have a 3x and a 4x. It could be 7 or negative 1 or positive 1 or negative 7. It's it. It doesn't work. So we have to flip those numbers, put 1 in the first binomial and 4 in the second binomial. Either the 1 or the 4 has to be negative. So let's let the 1 be negative first. For the outer terms, we have 12x, and for the inner terms, we have negative x. Together, that's equal to 11x. So that's good, but not quite there. We want negative 11x. If we switch the sign, then we have 3x times negative 4, which is negative 12x, and we have positive 1 times x, which is 1x. Together, those equal negative 11x. Aha! Therefore, the factored form of this quadratic is 3x plus 1 times x minus 4. We can apply the 0 factor property to get 3x plus 1 equals 0 and x minus 4 equals 0. If we solve that left equation, subtract 1 first, divide by 3, we get x equals negative 1/3. And for the right equation, we get x equals 4. Thus, the solutions to that equation are x equals negative 1/3 and 4, which happen to be the x-intercepts of the graph. Amazing. And now we've arrived at solving quadratic equations by completing the square. Some students get it right away, but many students need to see it a few times before they get the hang of it. The example says to solve x squared plus 6x plus 7 equals 0 by completing the square. And we're using that method because you can't actually factor this into two binomials. Here's the process. And first we set up. We subtract 7 on both sides. So we get x squared plus 6x, and I want you to write plus a box here, we'll fill it in later, equals negative 7 plus another box, and those two boxes are the same value. The next step is to identify what the box is. The shortcut is this. We take the coefficient of x, divide it by 2, and square it, which is 9. So we get x squared plus 6x plus 9 equals -7 plus 9. But let me explain that shortcut because it's very interesting, and it's the reason why this whole process is called completing the square. So let's draw a square that's split up into 4 quadrants. Above the top left square, I want you to write x, and to the left of that square, I want you to write x as well. Then let's find the area of that little square. So we do x times x, which is x squared. The terms on the outside of the square will eventually represent binomials that you can multiply together to get the terms that are on the inside of the square. In our setup step, we have a hint as to what goes inside the squares, inside 2 of the boxes. 6x represents the sum of the top right square and the bottom left square. So we could divide that into those 2 pieces. So 6x divided by 2 is 3x, and we put those in those boxes. So far, we've divided by 2. And if we know those boxes represent 3x and one of the lengths is x, that means the other length is 3. So we write a 3 above the top right box and a 3 to the left of the bottom left box. Now we can complete the square, meaning the bottom right of the square. To find the area of that square, we multiply 3 by 3, which is 9. So we've just squared 3. Do you see why that shortcut makes sense? 6 divided by 2 is 3, squared is 9. And do you see how students could get stuck on this the first time? But isn't it interesting? Let's go back to the process. We have x squared plus 6x plus 9. We could factor that into 2 binomials, and those 2 binomials are x plus 3 and x plus 3, the outside of our squares. And that's all equal to 2, which is the sum of -7 and 9. That means we have x plus 3 squared is equal to 2. Okay, we're almost there. Now we got to take the square root of both sides, so we get x plus 3 is equal to positive or negative square root of 2. Then we can solve by subtracting 3 on both sides. X is equal to -3 plus or minus square root of 2. That means there are 2 solutions, whatever -3 plus root 2 is and whatever -3 minus root 2 is. And those happen to be the x-intercepts that would show up on the graph as well. That's the end of Lesson 5A, solving equations by graphing and factoring. Thanks for sticking with me on that last example. Phew, that was a doozy. In the next lesson, we'll learn how to solve quadratic equations using the quadratic formula and how to solve equations using intersection points on the TI-84. Don't forget, if you have a question or comment, you can add it below. Thanks.